Hello, everybody. I'm excited to be here today with you. We're going to be going over a common problem that we see a lot of our customers trying to solve, and that's how they can accelerate their developers through the development, the setup of all of that infrastructure that they require in order to get their code from the development screen to the application, and in this case, on a container running in the cloud. So I'm joined today by Angel Rivera. We're going to talk to you about some of the common strategies, best practices, and ways to help accelerate those developers through that DevOps, the CICD pipelines, the deployment to those containers. So one of the first things that I like to reiterate to people, we've probably seen it a lot, is just some of the core pieces of DevOps. And that is, it's an iterative practice. You start, you do something, you measure the results, and then you create that feedback loop. So as we're going through this, we want to be increasing complexity over time. And this is where I see a lot of customers really kind of stall at the very beginning. They want that end product right away, but they don't want to go through the iterative steps to get there. And we really need to focus on simple pieces and then building more complexity over time so that each time we take that next leg up in that feedback loop, we're working on a solid base of known good stuff, whatever that is, the automation, the templates. And what we don't want to end up is needing to troubleshoot multiple layers of our automation process and pipeline. So that's where we talk about breaking this into little pieces. We want to start with a simple infrastructure as code template. Maybe it represents your container deployment with a little bit of auto scaling and a security group and a VPC, and you start there. You get that working. Then you start automating it. Now we've got a good template, it's working. We're going to start automating it. Can I make it deploy automatically? Can I make it scale automatically? Can I make it handle failovers and new versions with zero downtime deployments? So we start building in those pieces incrementally, testing them. Hey, it works. Now we can take the next step. And then once we have all of that working, we've got our templates, we've got our automation, then we can really start to focus on what I think is the best part about the cloud, and that's that on-demand self-service aspect. So we've got all these pieces, they work. Now we can give them out to our developers so that every time a new development project starts up, they don't need to go in and figure out how to set up a GitHub repo or a code commit repo with a pipeline and a build process. They can just go in, select it from a catalog of products and say, yeah, that's what I need. It deploys and they start checking in their code. So that's the ultimate goal that Angel and myself are going to be talking about today, is how to enable those developers to get to that point so that they don't have to set this up from scratch every time. So again, this is going to be a common theme with me this morning, is the start simple, right? So your first pipeline really should only have 3 steps to it, okay? The first part is we're checking in our code. We've got code commit. I'm going to focus on the AWS tools here. The same patterns will apply if you're using GitHub, GitLab, Bitbucket. Angel's going to talk about some other deployment practices and tools as well. But at the beginning, when you're first starting out, you really need to focus on get code in, build the code, and then deploy the code. And maybe even if, depending on where you're at in your technical pipeline, maybe you just get to check in code, build code, and then you'll work on the deployment later. And then once you have that deployment, you start talking about, okay, what am I deploying to, right? Is it a container? Do I just need, is my deployment target just ECR, for example, or Docker repo initially? Just get the container out there, and then we'll work on the compute later. But start simple, start building. At that point, you'll find it a lot easier than trying to flesh out an entire pipeline all from the beginning. Also, when we're talking about AWS, the code commit, code pipeline, the code build, a lot of that is run, and you get your intricacies and your details, those things that really parameterize and make a pipeline unique. That's in those build spec files. So this is another place where people can make things overly complicated, right? You should start maybe with one step where it it moves the files, it copies everything into place, and that's what we're seeing here. We're doing a build, we're setting up the directory structure correctly, and then we're building that Docker container and we're pushing it to ECR, all in one step. So maybe later on, when we're doing validation or security or something, we want to pull some of these steps out into another stage, but it's easier to do at that point. We've got a file, we know it works, we'll just pull those out. Now we've got a separate stage. So that's what we're trying to do here, is start simple, start with something that works, and then build onto it. So once we have that up and running, we've got our build working, we know that it's deploying to whatever it was we were shooting for, ECR or maybe directly to Fargate. Now we can build in things like validation. Okay, we can lint the code, we can check it, let's make sure all the files are there. Maybe we've got some basic practices within our company that we want to make sure, hey, the structure needs to be there, it needs to follow these patterns, you need to have comments in all your publicly available functions, something like that. We validate the code, it builds, it works, we know that. Now we can start to get even more complicated. We can add in things like security. So we have a lot of third-party partners that can do on-the-fly security scans. There's some AWS services that do this as well. We can start to inject those as stages into the pipeline along the way. So at this point now, we've built ourselves up. We know we've got code that works. We know it can deploy. We know it's valid. And now we're securing it. Are there dependencies in there that have known vulnerabilities that we weren't aware of? Did we introduce something along the way? So we want to scan that. We want to make sure that that code is meeting that security posture before it gets out in the wild. And this can get complicated as well. Do we need to scan the code itself? Do we need to scan the container image, for example? Because building the container can also introduce new dependencies. So I would argue you want to do both. You want to scan the code and you want to scan the container, and you want to scan the container as it's running in the wild as well. So you want to start building in these security layers as soon as possible so we find those before we publish out and deploy. So once we have all of those pieces in place, we've got our pipeline, we've got our deployment, we've got it all templated, we've got it automated, we've got our logging built in, we've got some solid framework. So now it's time to scale that out to multiple teams. We want all of our developers to be able to do this without building their own. And a lot of companies are seeking this not just to control what their developers are doing, but to standardize for security, for governance. We want to make sure that there's tags in there so we can do cost exploration later on. We want to make sure that it's following our security team's guidelines. We want to make sure that common one, buckets are not open, SSH ports are not exposed to the internet. So a lot of that happens by standardizing on templates and then getting developers to springboard off of those. So that's what we're seeing here. We want to package that all up and then provide that. We've got a really great service called AWS Service Catalog that allows you to deploy these resources on demand in any account, and you can spread that out to all your accounts. So some of our customers, for example, will have an account for dev, QA, prod. They'll have the same tools in all of those stages. That way, when they're promoting through their development stages, they know they're using the same infrastructure every time. And this not only speeds up development because they don't have to build it from scratch every time, but it also makes it more secure and more governable because now we know what's there, we know what we're expecting, and they're less likely to go in and change it because it's meeting all of those guidelines. Which is the final thing I wanted to say here is that this is something I see a lot of companies, their developers, their data engineers, they naturally just gravitate towards this on their own because it's one thing to know AWS really well, click around in the console, you can set everything up, that's great. But sometimes you just need something right now, we need to spin it up, and I want to know ahead of time that it meets our security standards, it's got the tags, I'm not going to get a call later on from a security person or the budgeting person saying, hey, why did you use this particular instance type? I can just spin this up, I know it works, and I know it meets all the guidelines for my company. And people just naturally gravitate towards that easier path. So everything I was talking about today is available out on GitHub in a repo where you can see how this works, all the templates, how it works with Service Catalog. You can set that up for your developers and really try it out live in your environment. But if that's not something you're specifically looking for, maybe you're not a team of CICD experts in deployment, and you really, or you want a company some help getting yourself there faster. This is something where you need to scale this out to developers. You're using GitHub or Bitbucket. That's where we have some fantastic AWS partners like CircleCI. And I'm going to introduce Angel Rivera today now, so he can talk to you about how we can take everything I showed you right here, and we can offload that heavy lifting over to a partner so that they can help manage not only the infrastructure, but the pipelines, the templating, and the sharing out to all of your sources. So with that, take it away, Angel.
Thank you, Chris, for that introduction into AWS and how to build software and build software better on the platform. As Chris mentioned, my name is Angel Rivera, and I'm a senior developer advocate at CircleCI. And I quickly want to mention a few things about CircleCI. I want to talk about a few concepts such as continuous delivery, DevOps, and CICD, so that folks are kind of level set during this presentation. And then I'm going to go through a pretty cool demonstration of how you can accomplish all of the things that Chris had talked about in his portion of this presentation on the CircleCI platform. So they're not much different, but there are some differences between the two platforms, obviously. But let's first start talking about CircleCI. So basically, CircleCI is a company that provides developers and operators, whoever it has a technical hand in building software, the capabilities of automation, and automation specifically for your continuous delivery processes. So the company was founded in 2011. This year is our 10th year anniversary, which we're really excited about. And we've grown the company in actually the past year or so dramatically. We're currently at over 600 employees, and we span across 5 continents, which is pretty interesting in and of itself. And essentially, like I said, we help teams build software quicker, more reliably, right? We have re-architected the platform back in 2017 to fit the current way of building software. So we've implemented some newer technologies based off of containerization, some of the cloud native type technologies that folks are using today. So we made that update in 2017 to include all of these new technologies and methodologies for building software. And that came out in version 2.0 of the platform. But we are currently at 2.1. And then I just wanted to share some information regarding like how much people are using, right? How much people are using the platform. Currently, I think we're well over 1 million builds per day run on our platform, which means, there's a lot of folks using CircleCI to build their software to control their continuous delivery processes, which I find really exciting. It's like we're building software at scale, right? Like legitimately doing that. So I just want to kind of give folks an idea of where CircleCI sits in the tool chain. So if you imagine, right, a continuous delivery process, as Chris mentioned earlier, a lot of folks struggle with the concepts of continuous delivery, right, and continuous integration, continuous deployment. They really do have their own way, right? Companies and teams have their own way of building software, and it's usually pretty custom. So when you introduce these concepts, a lot of those teams have a hard time kind of realizing how they can adopt and implement these concepts right within their software. A lot of times that happens because we're thinking about the technology, right? So as engineers, we kind of quickly pivot to, oh, here's this new service or tool that we can implement without really understanding why you would implement it. So that's why I kind of built this slide to kind of show how CircleCI fits into that. And hopefully this will kind of give you a better sense of where we fit, which is essentially in the middle of all of your software development processes, right? So if you look on the creation side, right, we're talking about where the developers are actually implementing continuous integration protocols, right, following those patterns to basically collaborate around your source code, right, to collaborate around on how you're building your software. And then we're in the middle there, right? As developers are doing that, we're testing the code. We're making sure that the things that need to happen in your processes are getting done. Similarly to what Chris was showing you in his previous slides and diagrams. So again, where they're orchestrating all of those bits. And then right on the logistical side, which is kind of like your deployment, right? You've got your application deployed. You can also leverage CircleCI to do things like monitoring, or at least confirming that your monitoring strategies are actually functioning the way you design them to, or you expect them to, right? So this also includes deploying your software, right, to whatever infrastructure you choose, like AWS, right? And you can use technologies such as Docker, right, containerized technology, to implement that on services like AWS, ECS, Elastic Container Service, which I'm going to show you how to do in my demonstration later on down this presentation. So again, CircleCI kind of orchestrates everything, right? And you can see this diagram here. You have continuous delivery set smack dab in the middle, but CircleCI is that automation, that platform that helps you coordinate and orchestrate, right, all of the elements within your software development processes. This is really important for many reasons, but I think the biggest and most important reason is for developers, operators, and anyone who's involved in the continuous delivery process to have a mechanism for to facilitate a feedback loop, right? To understand when things are completing or things are failing within the software changes that you're making, right? So that's kind of like the biggest takeaway from me is, that feedback loop, getting people from different roles and different responsibilities involved in that process early on so that, you can address things quicker and then move on with life, right? Because we're all here to hack on code or create new things with code, right? Whatever it is that we do, we just want to, create those things as quickly and and with quality and confidence as possible, right? And then move on to the next thing on our list to keep us moving and keep that velocity going. So more and more we're seeing, right, that our customers are really, really interested in creating things, like I said, reliably, consistently, and as quickly as possible, right? As efficiently as possible. And you don't want to sacrifice quality, right, over speed. And we do have some, because we run over 1 million builds per day on our platform, we know how people are, or how software is being built, right? So we have metrics because of our platform, and we run other people's builds for them. We do have metrics on what we call a high-performing team looks like, meaning, teams that are running their builds on our platform, and then maybe they're having failures. We know things like, just because of the data, right, the way that we're monitoring and we have to support and scale those builds, we know when folks are failing and how fast it takes them to fix those builds, right? So that's kind of a data point that is kind of unique to CircleCI because of the mission of the platform, right? So we've come up with some of these kind of metrics or things that we kind of watch and encourage our customers to watch as well. So one of the things is, how long does it take to push a change to our customers? So time to deploy is kind of a benchmark, if you will. or a metric that we measure. And then the other piece to that is the frequency of deploy, right? How many times per week does your organization or teams push changes to your customers? So the idea here is, if you want to increase your velocity, these are two factors that you should be watching, right? Or at least maybe even kind of setting the expectation for a goal. So again, we have access to a lot of data, especially from our customers and how they're building their software. And I wanted to share this information with you because I think it's pretty interesting. So in this graph, what we're looking at is the reduction, right, of time to deployment. So in the fifth percentile, people are actually reducing their time by using these CICD practices and principles by 30 minutes, right? And then they're also in the 50 percentile, 7.6 minutes, and then the 95 percentile is 2.7 minutes. So you can see that, right? These are huge numbers regarding how fast they're getting their changes out to their customers. And this is pretty fascinating stuff, and it's all due to the fact that, right, they're adopting and implementing these continuous delivery principles within the way they build their software in their software development life cycles or processes, and then they're using the automation to execute those processes in CircleCI's platform. So if you want to learn more about these numbers, we do a report. It's been, I think, 2 to 3 years. And we've been doing these reports regarding like how to leverage the metrics that we see on the platform and help the industry kind of define benchmarks and metrics for their teams. So we have this report. We called it the last one we did was 2020, and it's the state of the 2020 state of software delivery. Again, it helps if you want to take a look. There's a link there, CircleCI.ci /SSD 2020. That report will kind of give you some pretty cool insights into what we're looking at and what we think folks should be looking at if they want to increase their performance regarding continuous delivery. Just as a quick note, we will be producing a new one of these reports. I believe that I heard our content team say that they're going to skip 2021, and this will be released somewhere next year, and it'll be the state of 2022, the state of software delivery 2022. So yeah, if you see that there's no 2021, that's the reason. They've consolidated all that data into from 2021 into this 2022 report, and yeah, it all makes sense, I'm sure, there. But there won't be a 2021 report. It'll just be consolidated. So just want to call that out because I have a feeling I'll be getting some questions on that maybe in the future. So as I spoke to, velocity, developers are expected to go faster, right? And meaning produce these changes and make sure that you're producing quality changes quickly, right? We're also asked again to be confident in those changes and commit those changes or execute those changes reliably. So this is really important. I think confidence is the most important, right? When we're talking about software, at the end of the day, if you're not confident in the software changes that you're making or the way it's going to operate, there's going to be some issues, and they can get pretty intense and pretty serious if you're not careful. But thankfully we have continuous delivery concepts and principles, right? This kind of way of building software. And if you don't know what the definition of continuous delivery is, it's okay. The industry has, right? We come up with these kind of cool terms for things, and then there's probably like 20 different interpretations or definitions for these things. If you've been in this industry as long as I have, you kind of get used to it. But I'm going to share with you a definition which I think is pretty spot on. which continuous delivery, right, for all intensive purposes, is the practice, and this is really important, the practice, it's a concept, right, of building, testing, and delivering changes to code and user environments using automated tools. And I've bolded the important bits in this, but essentially, right, it's still a practice. You still have to kind of create a schema or a strategy on how you're going to deliver this software. And it all starts with humans, right? Like technology is all about humans. The way we build our software, it's all about humans, right? We're delivering this software to humans. So it just makes sense that, right, if you're building something, it requires humans, and continuous delivery is a practice or principle that we should use and build right to our own standards to get that software changed and delivered. So within continuous delivery, we have this concept of continuous integration, continuous deployment, also known as CICD. I just want to kind of quickly cover these concepts as well. So with continuous integration, right, like, again, I like to look at things as principles or talk about them as principles. And continuous integration, these are some of the core concepts or elements, patterns that kind of encompass continuous integration. And essentially, right, the rules are, or yeah, some of the guidelines are write and commit code as often as possible. As Chris mentioned earlier, right, we kind of we tend to tackle things as a whole, and instead of, kind of digging a little deeper, peeling back some onions and encapsulating things in more smaller bites, right? So smaller, more manageable bites. So that's where this kind of write and commit code often directive kind of comes from. And it does work, right? So if you take concepts that are pretty complex, break them apart into smaller, more digestible pieces, you're able to tackle the problems a little bit more clearer, right, and more efficiently, and then apply this rule to it. So again, write and commit your code often in smaller bits, right? So that requires you to write a few functions and then commit them, test them, make sure they're good to go, and then commit them to a shared repository. And that right there, the shared repository bit is very useful for facilitating this collaboration we're talking about around code. So if you're committing to a shared repository, the rest of your team has a nice understanding of kind of what you're up to in the code, and then also can get ahead of, be proactive and get ahead of some of the work that they're going to do that may overlap with yours, right? So if you're changing some code and they're going to have to come after you and change some code, at least they have an idea of where you're headed, and they can mentally prepare themselves, right, for those changes and organize kind of how they're going to work. So that's what kind of the benefits of continuous integration, right? But the biggest benefit, for sure, for me at least, is, and it's my favorite, is the fast feedback loops, right? So for the individual developer, if you're writing code and you send it off to your continuous delivery platform or your CI/CD platform, you want to know when things are broken as soon as possible so that you can fix those things, right? And the fast feedback loop is super important, and that's what the platform CircleCI also provides. Is that hey, we're going to execute your builds. If they fail, you'll know right away, and then you'll be able to go back and fix it before you kind of change your context, right? Sometimes when we're developing software, we're in a flow, and we do a lot of context switching. I find that if I know, in a 10-minute span or 5-minute span of after committing my code, if I know there's some failures, that's a great way for me to kind of take a break, maybe drink some water, coffee, whatever, come back. Did my changes work? Great. If I'll move on to the next thing. If not, then I'll go back, fix it, right? So that's what I mean by fast feedback loop, is just being notified that, hey, there's an issue with your build. So when we're talking about continuous deployment, right, the other side of the CI/CD coin, the CD portion, that's pretty simple, right? We're just automating. The principles are essentially, right, to automate the creation of your release artifacts, whatever that looks like, right? It could be WAR file, could be a tar file, could be a .msi file. It could even be a Docker container, which is what we're going to wrap our application in for this demonstration or for this presentation. So again, creating these release artifacts, and then we can even deploy, right, these artifacts to whatever environment. Could be a Kubernetes cluster, could be an Amazon ECS cluster, whatever you want to deploy to, that can be automated in these principles, right? So you create these strategies on how to do that, and then you also have the ability to validate these applications and services once deployed, right? So obviously, if you deploy something, the deployment may be successful, but you still want to make sure that the application itself is actually running, right? A successful deployment doesn't necessarily mean that the application is actually running, right? Those services are actually running. There may be a configuration issue that wasn't caught in the deployment, right? So you want to validate that those services are up and running. And then finally, you want to monitor those services, right? And make sure that the state of that application is exactly where you want it to be. And then I always tack on too, with this monitoring bit, if you have the ability or capabilities to add resiliency, which is a recovery type of function for your services and application, I would strongly advise you to look into those things, right? So like, what I mean by that is if you deploy your application, it's running great, and you set up, right, some surveillance tooling, maybe CloudWatch or, the other tools that Amazon has or some other third-party tools, you definitely want to have a way for your system to, if it just encounters, it's going to encounter issues, right? If it's used in the public sphere, I don't care what kind of application you wrote, it's going to have issues eventually. You want that application to be able to fail gracefully and then kind of respawn itself or recover, right, from those failures quickly. It's very similar to kind of like the chaos engineering concepts that are out there today. But again, resiliency is really important, and it's the future. I think, if you're not in that stage internet mindset yet, definitely start looking into it. And reInvent's a great event for that, right? So what I described, right, obviously is CICD, as I mentioned, right? The continuous delivery, the continuous integration, continuous deployment, all combined provide this concept of CICD. And again, right, I was talking about concepts. And I like to talk about DevOps real quick and associate or relate how, or discuss how CICD and DevOps are kind of related. This infinity loop kind of shows you the continuous integration, continuous deployment way of, or concepts, right? And these are, this infinity loop has kind of the core things to building software, right? The core elements of building software. But I wanted to show how each lobe kind of sits within the DevOps sphere, right? So DevOps is a concept where it's designed to help developers and operators kind of work better together, right? So it's more of a cultural kind of concept. And I know a lot of folks in the industry and some organizations have, included it as a term within their products, right, for product marketing. But I'm here to tell you that it's a cultural concept, right? And it was born in the community, and it's actually managed by the community. But right, you have the developer kind of responsibilities in the dark blue, and then you can see like the transition point, which is appearing to be in the release phase, right, for the operational folks. And again, DevOps is designed to be a way to kind of give the development and operations teams, the technical teams, a way to work and collaborate, coordinate better, right? And some people, some organizations and teams take it to the extremes of like, hey, if you're a developer, you build it, you own it. And other teams, right, customize the DevOps experience to be something a little less extreme. But in any case, there's no right or wrong. I'm just here to say that for my definition of DevOps is essentially DevOps should basically mean to teams and however you implement it, but it just should be smoothing over those transition points between technical roles, right? And things like I'm a developer. I focus on my code. The things that you should focus on are those gray areas that really hurt that transition, right? So it's like throwing the responsibilities over to ops. I would focus on what are the pain points there, right? What happens when a developer is in your organization or in your team? What happens when the developer is done with his portion, right? Passes all the CI/CD bits and all that good stuff, and operations has to kind of take over, smooth out those pain points in that transition, because that's the gray areas, right? That you need to focus on to make it a smoother transition, more collaborative, more coordinated, right? People can just actually freely communicate and lend their expertise. All right, these are all experts in their own field. They should be coordinating, collaborating, and managing those pain points and barriers, and then that'll reduce those barriers actually, and create that quick velocity that we're all talking about. And also, right, keeps everyone in that feedback loop that I keep talking about. It's really important. Because if you just have one person responsible for the whole thing, I don't think you're really like gaining anything except probably some bad morale on your teams. To be fair, I mean, I've been in this business a long time, and everyone is they're experts in their own field. They should be able to learn as well, right? In that concept. Anyway, I'll move on from DevOps, but if you have any questions on my opinions, I'm definitely here to share. So all of those things I talked about, right, are practices and principles and the way we should do things on a human level, right? But all of that means nothing without automation, right? You don't get any of the consistency, you don't get any of the reliability, you don't get any velocity, right, without automation. And then ultimately, you don't get any of that confidence that I was talking about when we're deploying software and making these changes. So automation is critical, and that's where CircleCI comes into play, right? And when you add automation to all of those practices and principles, you're bringing your software and continuous delivery processes to life, right? The automation is that facilitation of executing those things for you. And when you're adding that automation, we tend to call that a CICD pipeline, right? So this is a continuous integration, continuous deployment pipeline. Now, just because you're using continuous integration, continuous deployment, doesn't mean you have to actually deploy things, right? So I would always recommend the continuous integration piece. But if you're okay with not having a continuous deployment strategy yet, or because maybe you just don't have experience with it, that's okay. But at the end of the day, that can be your end goal is, hey, I want to continuously deploy these changes over time. So this is what a continuous or a CI/CD pipeline looks like in the CircleCI dashboard. It's actually the example that we're going to use within this demonstration. So you're going to see things like scanning scanning an application for vulnerabilities. We're going to run a couple simple unit tests, right? And then we're going to build a Docker image, deploy the AWS ECS infrastructure. Now, that's going to involve things like infrastructure as code, which Chris mentioned earlier. In this case, we're going to be using an application for infrastructure as code called Terraform. It's a pretty cool application, but basically all of that infrastructure is going to be defined. It's going to be pretty cool. I'll go through that demonstration, so I won't talk too much more about it. But again, the other step here is smoke testing, right? So what I'm showing you here is an example of a quick test to ensure, right, once I deploy, that my application is actually up and running. And this can be more extensive if you like. I prefer not to have that, more extensive testing. That could be for another phase, a stage of a pipeline. But for this demonstration, we're going to do a quick test. And then I've added a prove destroy, so that this will show you a way to build this kind of confidence testing, right, smoke testing type capabilities inside of a CI/CD pipeline that you can build all this awesome infrastructure and then tear it all down, right? So it's kind of ephemeral. It doesn't really matter. It's just there for testing and then blow it away, right? And not have any trace of it. But it will give that confidence to your release teams that, hey, this thing was actually deployed to whatever target environment, in this case ECS, and it worked, right? So this artifact is legit, it's good, and we can move on with life. So yeah, one thing I wanted to call out for this demonstration, we're going to be deploying an ECS cluster, but the underlying nodes are going to be based off of Amazon's Graviton 2 compute nodes, right? So these are ARM capable or ARM powered compute nodes that AWS has devised and engineered and now published. So we're going to be using these ARM compute nodes to prove that, hey, you know what, CircleCI can also help ARM developers now, right? Before we didn't have this capability, but now we do. So like in your pipelines, I'll show you how you can leverage CircleCI to run your builds on ARM powered compute nodes. So it's time for our demo. I'm again going to show you that pipeline, and then we're going to dig deep technically into how all of these things are, how you can perform all of these things within CircleCI and AWS. So before we get started with the demo, I just wanted to introduce all of you to the code that we're going to be using for this demonstration. You can find it on GitHub. At CircleCI, we have a public kind of area or organization that we have all our examples on. So you can find it at circleci-public/AWS CircleCI Monetization Workshop code. And that's the project that I'm using. Again, I just wanted to share this with everyone so that you can jump on it later and maybe follow along. We also have a workshop that's associated with this code base. But I just also wanted to let you know that I'm going to be using a fork of this for this demonstration. So what you're going to get is the workshop version. And you can find that at AWS Marketplace, CircleCI Workshops, .io or something like that. We'll share the URL with you later on after this presentation. So let's go ahead and look at the code base. Again, this is the project that we're going to be working with, and this is my fork of the project. I just wanted to call out that this project is essentially a simple Node.js application, right? That we use just to show the capabilities. The application is not the focus here. The focus is going to be the pipeline. So let's take a look at our CircleCI CI/CD pipeline. So the way we create or define and execute pipelines in CircleCI is by a data structure called YAML, right? And within CircleCI, you have to add, in order for you to kind of marry up or create this definition and execution of a pipeline, you have to create, within your project, you have to create a .circleci folder, which is what I got highlighted here. And within that folder, you must have a file called config.yml, which is, again, config.yml equals YAML, right? CircleCI leverages the YAML data structure to help folks define their pipelines, and then it's also used to execute those pipelines. So there's a little bit of learning, but not much, right? Like it's a data structure, so you just have to understand CircleCI's, I guess, keys for their YAML and how they define specific things. In CircleCI, there's essentially 4 different types of keys that you must the core elements, right, to a pipeline. Number 1 is I would say jobs. So jobs are a grouping of commands that you want to execute to achieve a certain result. And if you look at the line number 9 there, we're talking about tests, right? Running tests. So we want to execute a job. This line here, number 9, is just a label for the job. It's just a name for the job. And then as you can see, we have what we call an executor. This thing here is essentially defining where to run the code, like what type of node or runtime to run in. In this case, we're going to use a Docker container. That's where that Docker key comes into play. And then, of course, if you're using a Docker container, actually, if you're using any kind of runtime, you have to supply some sort of image, right? Some sort of operating system or operating environment. In this case, we're going to use our CircleCI convenience images for the node application. Once within the job, you have these things called steps, and these steps are essentially a list of commands that you want to execute within that job. So since we're wanting to test our application, we're going to need code, right, to run. Actually, in every step of the way, if you're going to do anything with your code, you need to actually get that commit
pulled down, right? So this checkout here is just an alias for git clone. Once we have the code, we can start implementing this concept of a node. Concept of an orb. So orbs are essentially packaged up functionality. It's really great for keeping things concise and terse within your YAML declarations and your YAML commands. In CircleCI, we have this, again, concept of orbs, which is packaged up functionality. As you can see, we're going to be doing some Terraform. We're going to be building a Docker image. We're going to be scanning our applications with Sneak. So these are orbs that are built by CircleCI and our partners to enable that functionality, more easily enable that functionality within the pipeline. And this is essentially what I'm showing you here. One of the other elements I was talking about, the 4 elements. Orbs is a key, and this is basically like an import statement. Now, if you jump back down to where we were on line 14 here, the node / install packages is a command within that orb that I talked about, right? And in this situation here, we're just leveraging some of the commands and parameters for the commands. In this case, we want to override the CI command, and we just want to call an npm install, as well as provide a cache path. So in this case, where the orb itself hides kind of like how to provide cache capabilities, save and restore. We just encapsulate that functionality into one call, and all you have to do is pass it a path for where your dependencies will live. In this case, it's node_modules, the kind of the default. So the next step here is a run command, right? And this is a list of commands. So this is how you kind of just create those things that show up in the CircleCI dashboard, which I'll show you later. But if you can see, I gave it a name, and it's basically run unit tests. And then the command, right? It's a multi-line command. If you know anything about YAML, pipe allows you to, keep a multi-line kind of situation going when you're listing things in that pipe, using that pipe. So we're just running the same unit tests, but with different results, because you can literally create test artifacts, right, and pin it to the build. So it's way easier for your teams to kind of go back and look at the test results if they need to. And then, right, we have these store test results. So again, all of these things are commands. These store test results are kind of that special CircleCI goodness for defining specific functionality within the YAML syntax. So before we go any deeper, though, I just covered jobs, right? That's essentially what one of the core elements. The other element is these run commands, right? So you're running these commands, and that's kind of like orbs, jobs, commands are a core element. Executors, right? The node that we're running on is also important. And then finally, we have this concept of workflows. So once you build out all the different kind of jobs, which I'll jump into more specific jobs in a minute, but the workflows is how you would orchestrate all of those things. So if you look here, right, the workflow basically created is called build, and then it has a jobs list, because workflows orchestrate jobs. You have to build a jobs list. And again, these are just the things you want to run in your pipeline. So once you define all the jobs, which we've done in the jobs list, you can then use them in your workflows list, right? This is how you execute. So you're basically saying, hey, for this build workflow, I want these jobs to execute. And as you can see here, we're executing jobs in parallel, right? The reason why I say that is these 3 jobs will run simultaneously. Now, if you need to build a dependency, like in our Terraform deploy AWS ECS job, which actually builds an ECS cluster using Terraform, we really need to build a Docker image first, right? Because the whole end game is to deploy these changes from this application in a Docker image or a Docker container on an ECS cluster, so that we can run some tests. So in order for us to do that properly, we need to create a dependency, and that's where this require statement comes into play. Is saying here, run this Terraform or execute this Terraform deploy ECS job, but only after the build Docker image has successfully completed, right? So that's how you build that dependency. Okay, so I kind of covered quickly the core elements. You can read more about this stuff in the CircleCI documentation. We have pretty good documentation about it. And if you don't have any issues, just reach out to me and we can talk about them later. Now, I just want to, in the interest of time, kick off a pipeline to demonstrate that, how this all works. So let's go ahead and make some changes to our application, which is kind of how the flow will be in actuality, right? So I want to change my message here to say that, node server running on port, let's say 5000, which is the application's execution, the port that it's going to be listening on when it's executed. I'm going to save that change. I'm going to come down here and I'm going to go ahead and commit this change. So let's do a git status to make sure we see what we're looking at, right? It's just the application.js. So I'm going to do a git commit, and then I'm going to just say the app.js application, and then I'm going to give it a message, right? And I say updated, console message, right? With port, and then I'm just going to save that, or commit that, I should say. Now that we've committed the change locally, this is how we're going to basically trigger that pipeline I just showed you. We're going to do a git commit, and then we're going to do a push. And once we do that, disregard, we're going to do a git push. And once we do that, it's going to push our changes upstream to GitHub, to our repository. Then we're going to jump over to the CircleCI dashboard. And as you can see, my pipelines have started or kicked off, right? The code changes were detected by CircleCI. It kicked off my pipeline, and now it's running the application. While this is running, it's going to take a few minutes, right? So we have the ability to see that it scanned our application, it ran our test, they passed successfully, right? And now we have that dependency that I was talking about in our workflow, right? The building Docker image job is running. The Terraform deploy will not occur until this build Docker image is successfully completed. And the reason why is, right, we need a Docker container or Docker image to deploy as a container in our ECS cluster. So while that's going on, let's go ahead and take a look a little bit deeper into like some of the really cool jobs. This right here is our Docker build image, or our build Docker image job. And essentially what's happening here is we're building a Docker image for an ARM capable infrastructure. So what I mean by that is CircleCI now has the capabilities to allow you to build for ARM architectures. And essentially, remember when I talked about building your code on an environment, a compute node, or an operating environment? That's exactly what we mean by a resource class. We're giving you the ability to say, hey, all right, I want to do Mac OS, or I want to do a medium-sized compute node, which has more CPU, more memory, or an extra large, which has even more CPU and memory. But in this case, we want to use an ARM level or an ARM class type executor. We are defining that with the ARM.medium. So that's enough horsepower to get us through what we need to do. But again, CircleCI has native ARM support now, so to enable you to run your code on ARM capable hardware. So let's go ahead, look at steps again, right? We're checking out the code. We're running some more orbs, right? We're using that Docker check orb commands, and that's essentially just logging into Docker Hub. And again, right, look, some more orb goodness. It's just a Docker build. So this simplifies the Docker build process. And I'm providing a Docker image name based off of native CircleCI native environment variables, right? So this is a good way to hide or mask secrets within the config definition of your pipeline. So this is very useful for when you have sensitive data that you have to use in your calls or in your execution of your code, but you don't want to expose that to the public, right? So that's why you see like the environment variable Docker login. I don't want to show that, even though it's not that sensitive, but you get the point. So why don't I jump in while our let's go take a look at our dashboard. While this is happening, we'll drill in real quick. Terraform has kicked off. It's building a lot of things, right? This is building soup to nuts of VPC, security groups, internet gateways, internet routing. It's connecting all the dots. It's building an application load balancer. It's building an application scale group, or I'm sorry, it's building a scale group for the compute nodes, because we need that capability, right? If to scale up and down within the ECS cluster. And by the way, it's building it using ARM technology, which is called AWS Graviton 2. Those compute nodes will be ARM powered. So jumping back over, I just wanted to cover real quick, like how to execute this stuff, right? So we're building our Docker image, and here's the definition for deploying to AWS, right? Essentially, like I said, we're kicking off a Terraform code to build our provision our infrastructure and deploy our Docker image. And this is what it looks like, right? So if you're interested in learning how I'm doing this, I'll run through this really, really quickly, and then we're going to look at the progress we're making. So essentially, right, again, we're going to use a machine type executor with the ARM capabilities. We're going to check out our code, and then we're going to create, since we're using Terraform Cloud, we have to create a Terraform file with the secrets, right? And that's, again, here's some sensitive data. You're not going to see my token, but the runtime will be able to extract that information from the platform and, you know, use that environment variable, the values in that variable, to create that file. And then once I have that instantiated, then I'm going to use my Terraform Orb to install. We have an install feature that basically downloads the client that you need for this specific architecture and operating system. Oh, I didn't mean to do that. But basically, if you go back to Codebase, let's go ahead and take a look at the Terraform initialization, right? All you need to provide it is the path where your Terraform code is, which is the Terraform folder, and then also inside the ECS folder. We're going to run a Terraform plan to kind of figure out like a preview of what's happening. These are very useful to understand how your Terraform is going to deploy and what it's going to deploy. And then finally, we're going to execute the Terraform code, right? This is the apply command. We do have our Orb has an apply command built in, and it's a little bit more terse, but I like to show and use more custom things, right? So in this command, I'm using Terraform variables, right? So I wanted to show how you can, you know, leverage the Orb to initialize, install, and plan, and then actually execute using a more robust execution outside of the Orb. So you can kind of mix and match, right, the functionality of these Orbs. And then finally, we're basically going to export. So once everything's done, we have to get some information to do a smoke test. I like to test my deployments after they're deployed. So I need to grab this information, which is essentially the public-facing endpoint or load balancer host name, so that I can then, in my subsequent job, deploy a smoke test or do a smoke test against that running cluster to make sure it's working. So that's essentially it, right? Oh, let me jump here real quick. Yeah, when we're saving that endpoint into an environment variable, so to persist that like information between jobs, you would use a workspace, what we call a workspace, and all that does is gives you the ability to save files or information in files to a specific like mounting point, and then you would, and I'll show you in subsequent jobs, be able to mount that information and then use it, consume it in later segments of your pipelines. So let's go ahead and take a look at our pipeline and see where we're at. So our Terraform job has completed. So that means we have provisioned a whole new ECS cluster powered by AWS Graviton 2 compute nodes. Let's take a look at the apply command, right? This is exactly what I was talking about. Executed my Terraform code and then produced the load balancer name. Again, we need this host name for subsequent jobs, especially for our smoke testing job, to make sure that our deployment is actually functioning, right? And we built a pipeline specifically for that, or a pipeline job specifically for that. So let's go ahead and take a look at the smoke test deployment. It passed, right? So this thing should be up and running. Let me go ahead and open up a new browser, and I want to test. So I got the host name from the job, and it's working, right? This is fully functional on our newly created ECS cluster powered by Graviton 2 compute nodes. So let's take a look at Amazon. So here's our cluster. It's called the AppArm version 8, or version 8. That's the CPU version of the ARM spec. So let's take a look at our ECS instances. There are the 3 compute nodes that I talked about. That's pretty cool. But then I want to show you, getting back to the pipeline, you know, this is working. We obviously tested the application. ECS is up and running, right? But let's get back to the pipeline really quickly. So this is our smoke test. If you want to take a look at, our smoke test of the ECS. So we got an OK200, and then the body of the site contains a certain text. That's cool. So let's go back to the build pipeline. Finally, right, like we have a way to change some code, build a Docker image based off of those changes, create an ECS cluster, provision a newly created one, and then smoke test our artifact or our container image or our changes on an actual target environment. And then we can essentially destroy it all. So I have approval command. I don't need this infrastructure anymore because I've proven my test. I'm going to go ahead and destroy it. So I'm going to click the approve. And what that does is kicks off my destroy Terraform job that I spoke about earlier. So that's basically the demonstration in a nutshell. Again, if you want to reach out to me, you can hit me up at Punk Data, but you can also grab this code base at the GitHub project that I mentioned earlier. Let me just put that up on the screen for you, which again is the AWS CircleCI modernization workshop code. Thank you.
All right, thank you so much, Angel. That was really great. And I'd like to reiterate something you said in there about the DevOps pipeline and those the infinity curve. I really like that because it shows you that this is a never-ending procedure. We're going to do some stuff, we're going to measure it, we're going to get feedback, and then we're going to plan, iterate, and go through it all over again. And it's important to see that also when we talk about doing simple steps at a time. Like Angel said, maybe you're not ready for continuous deployment, but you're ready for continuous integration. So start where you are at, take it from where your people learn and grow the steps as needed through that iterative process. And along the way, don't do it all yourself. Lean on partners like AWS with the services and the infrastructure that you need to get these things done. And also lean on partners like CircleCI who can handle the orchestration, the automation, and the sharing of these things. So where can you see this? So we have a great workshop on the AWS Workshops page for CircleCI. You can get on there, you can try it out hands-on. You can also find CircleCI on the AWS Marketplace. So go out there onto Marketplace, it'll roll up to your monthly AWS bill. You can try it out, work with the product, see if it fits for you and your company. And then, like I showed you earlier, the slides I had, there's a GitHub repo with all of those templates there. If you want to try out a pipeline with Service Catalog, check that out on the GitHub repo. So we want to thank you very much today for coming out and hearing about the CICD pipelines, DevOps, and what CircleCI can do to help you get there faster, easier, more secure, standardized, and really work on that automation and the templating, the infrastructure as code to help your developers deploy applications faster.